So now we are going to discuss about part 3.3 of operators and decision contracts. Part 3.3 is if-else, ternary operator and switch statement. It's quite important. We've already covered the earlier parts 3.1, 3.2 and now we are going to discuss about 3.3. So if and if-else, the rules. In Java, the condition inside an if statement must strictly be a boolean expression. Java does not allow integers, objects or null to be used directly as conditions. It has to be a boolean expression. For example, writing if x where x is an int will cause a compile time error. Instead, you must write an explicit comparison such as if x not equals 0. Another common mistake involves omitting curly braces. If braces are not used, only the very next statement will be executed because that belongs to the if block. Other statements will be omitted. Any statement that follow will execute regardless of the condition, right? So even if it is true, false, whatever, the third statement, if it is not within a curly brace, it will execute even if they appear indented. Indentation doesn't mean much in Java because indentation has no meaning in Java compiler, unlike many other languages. Only the first statement after the if is controlled by the condition. In an if-else if chain, Java evaluates the conditions from top to bottom. As soon as one condition evaluates to be true, that block executes and the rest of the chain is skipped. The final else block is optional. It runs only if none of the preceding conditions are true. So this is a very common trap involving assignment versus comparison. Consider the condition if active equal to false. In this case, what happens is that it uses a single equal sign, right, and not an assignment. So this is an assignment and not a comparison. Many people assume that this would cause a compile error, but in Java it actually compiles successfully. This happens because a boolean assignment expression returns the value that was assigned. So active equal to false assigns false to the variable active and also evaluates to false. Since the condition evaluates to false, then if block is skipped and the else branch executes. Right? The if block is skipped and the else branch executes. At the same time, the variable active has now been changed to false. This behavior only works with boolean variables. For example, writing if x equals 10 where x is an int will cause a compile type error. This is x equal 10 what? It's not a boolean expression, right? So it will lead to compile time error. That is because assigning 10 to x produces an int value, not a boolean. Since the condition in an if statement must evaluate to a boolean, Java does not allow such expressions. The ternary operator provides a compact way to write a simple decision in one line, right? Its structure is condition, question, value if true, value if false. Java first evaluates the condition. If the condition is true, the expression returns the value before the colon. If the condition is false, it returns the value after the colon. One important rule is that both possible values must be type compatible so that Java can determine the result type of the expression. For example, int x is equal to true, question 10, colon 20. Both values are integers, so the statement compiles and works correctly. However, the following will cause compile time error. Int y equal to true, question 10, colon within quotes text, which is a string, right? Here the values are int and string, which are incompatible types. The ternary operator can also be nested, meaning one ternary expression can appear inside another. In exam questions, you may be asked to trace a nested ternary expression. The best approach is to evaluate the innermost condition first and work outwards. Okay. Like here, this result, int result a greater than 10, then question a greater than 10, question 2, colon 1, right? Here within bracket, we shall first evaluate that, okay? So what is a? A is equal to 10. So is a greater than 10? No, right? So result will be 1, okay? Is a greater than 0? Yes, 10 is greater than 0. Then we go to the first option. Within that we check, and so we find that a is not greater than 10. So obviously here it will not be 2, it will be 1. The switch statement in Java supports only a limited set of data types. It can work with byte, short, char, int, string. The string is from Java 7 and enum types. The corresponding wrapper classes byte, short, character, integer are also allowed. However, long, float, double, boolean cannot be used in a switch statement. Attempting to use this types will result in a compile time error. Each case level must be a compile time constant. We must remember that very well. This means the value must be known during compilation. Valid case levels include integer literals such as case 5, character literals such as case within quotes A, and string literals such as case within string within quotes hello. You can also use final variables provided they are initialized with a literal value at the time of declaration. A regular variable cannot be used as a case level. For example, writing int x is equal to 5 followed by case x will cause a compile time error. The default case runs when none of the other cases match. It can appear anywhere inside the switch block, at the beginning, in the middle, or at the end. Fall through. Let us discuss fall through, the number one switch trap. Okay, fall through is one of the most frequently tested and often misunderstood behaviors of the switch statement. The key rule is that once a case level matches, Java begins executing the code for that case. If there is no break statement, Java does not recheck the next case level. Instead, it simply continues executing the following statements. This behavior is known as fall through. For example, suppose the variable rating has value b. When switch statement reaches case b, it matches and executes the code for that case, printing good. If there is no break after case b, Java continues executing the next block of code without checking whether next case level matches. As a result, the code under case c also runs, printing average. Execution then stops after Java encounters a break statement or reaches the end of the switch block. Therefore, the output would be good followed by average, not just good. In exam questions also, you may see a switch statement with missing break statements. To determine the correct output, trace the execution step by step. Once a case matches, execution continues until a break is encountered or switch block ends. Now we are going to discuss case level rules, compile time constants. Case levels in a switch statement must follow strict rules. Each case must be a compile time constant, meaning the compiler must be able to determine its value before the program runs. Literals such as integer and character values are valid case levels because their values are known at compile time. For example, case 5 or case within quotes A are both valid. You can also use final variables, but only if they are initialized at the time of declaration. For example, final int max is equal to 10. Since the value is fixed and known during compilation, it can be used as a case level. However, blank final variables do not qualify. For instance, final int num, and in the first line and in the next line you are assigning num is equal to 10. Even though the variable is final, its value is assigned later, not at the declaration. Because of that, because the compiler cannot treat it as a compile time constant, using it in a case level results in a compile time error. Regular variables are never allowed as case levels because their values can change during execution. Additionally, duplicate case levels are not permitted. Even if two case values appear different but resolve to the same value, the compiler will report a duplicate case error. Default placement, default can go anywhere. Many developers, they assume that the default case must appear at the end of a switch statement, but this is not required. According to the Java specification, the default block can be placed anywhere in the switch, at the beginning, in the middle, or at the end. The key execution rule is that the default case runs only when none of the other case levels they match the switch expression. If a matching case appears earlier in the switch, Java begins executing from that case and continues normally according to switch flow. The program will only execute the default block as a fallback when no other case matches the value. The default block also follows the same fall through behavior as other cases. If the default block does not contain a break statement, execution continues to the next statements in the switch block. This means that execution can even fall through into a case block that appears below the default block. Let's come to the practice question. So we see int x is equal to 2, switch x. Then case 1, system out println 1, case 2, system out println 2, case 3, system out println 3, then break, default, then system out println other. Answer is B, 2 and 3. X is equal to 2, it matches case 2, then it prints 2. but there is no break there, so it falls to case 3. There it prints 3, after that it encounters break, right? So break, at that point it exists and default never runs because the break stopped execution. Okay, so answer is B, 2 and 3. Okay, that's it in this video. For more such practice questions and answers and fundamentals too, you can visit https://javaLearnClusterMicro.com. You will get 29 full-length practice tests there and 1624 practice questions. Thanks for your time.